Well, hello there! I hope you're having an amazing day and that you're feeling as excited as I am about our today's topic, because today we're talking about data types. You probably already have some basic understanding about this topic, because we had to cover it, at least the basics of it, in order to cover some different topics that we covered up to this point. But that was just scratching the surface of this topic. Data types are basically one of the most essential aspects of every programming language, which of course includes Rust as well. That is because data types tell our compilers how to interpret bits of memory and how to actually work with them. If you remember our video about variables, inside of it I showed you a couple of examples where exactly the same sets of bits give us completely different results. So we could get letter A, or we could get 25, or we could get minus 50, or we could get true, or something like that. Because same bits can give completely different results based on the fact that they have different data types. Also, a very significant thing to know is the fact that Rust is statically typed programming language, which means it has to know for each variable we have in our program what is its data type before we even run the program. And that is because Rust is statically typed programming language. In Rust, you are able to have workarounds for this, and you can evade this limitation, but to do that you have to use some of the more advanced concepts that Rust provides us with. So we are not going to talk about them yet. Okay, and I think that next question we should answer is going to be what types of data we can work with in Rust. So what things from our real life we can translate into our Rust programming language and work with it inside of our code. And let's say that we have three main, most straightforward categories here. The first one are going to be numbers. And when it comes to numbers, we have a few flavors here as well. We have signed and unsigned, we have integral and numbers with decimal points, and that's basically it about numbers. On the other hand, we have letters, and letters can be characters or they can be words, sentences, which is basically strings inside of programming terminology. And the third category are going to be conditionals. So basically, you need a way to be able to tell our compiler that for some statements we have only two options, and those options are true or false. So we are just asking a question, like yes or no question, and there are only two answers to that question: yes or no, or true or false. And in programming, this is a very essential data type, because we use it in so many different scenarios. Of course, you need to be aware of the fact that our CPU basically knows nothing but ones and zeros. That is all it is capable of understanding. Nothing more, nothing less. Of course, that is unless somebody from the audience points out the fact that we have quantum computers right now and they do not use only two states. But sadly, I still do not know quantum computing. I think it would be a great idea to master quantum computing and then get back to this video and edit it again and just say, hey, we also have this option to have more than just two states and ones and zeros. But yeah, I'll have to work on that, because sadly, right now, I have no expertise there. So for now, we are just going to stick to ones and zeros. Well, that's all fine and dandy, but what do data types actually do for us? What they provide us with? What is their value? Practical value? Well, first of all, data types allow our compiler to actually know how much memory it needs to allocate and in which memory types it needs to allocate that memory in order to be able to store all the data that we want to work with, to have at our disposal, so to say. Also, data types will allow our compiler to actually know how to translate bits in memory into something that we actually expect to get as a result, and also to translate the stuff that we send to compiler, to write in our code, and then transform it into bits in memory. So basically, it teaches our compiler how to translate stuff from machine language to human readable language, and from human readable language to machine language. And finally, it will tell the compiler and let it know what operations are available for specific data types. Because you sure do not have same operations available at your disposal for working with numbers as the ones you have when working with characters or conditionals and stuff like that, because it wouldn't make sense to multiply true with false, right? Great, now that we got that out of the way, I think it's a perfect moment to extend our knowledge about data types with the basic categorization, because in Rust we have two main categories for data types. The first one are going to be scalar data types, and the second one are going to be compound data types. So, what are we waiting for? Let's cover both of them. The first category that we're going to cover are going to be scalar types. So, what does it actually mean for a data type to be defined as scalar data type? So, data types that are inside of this category are all very simple. They all have a single value, and that value is of predefined, well-known size. So we already know, before we even started working with the data type, we already know how much memory we need to allocate for it, and that memory is going to be allocated on stack. Which makes working with these data types very simple and straightforward, because we know that the data is on stack, and we know how to access it, we know how to manipulate it, and working with these types of data requires very little effort from our CPU. And now the main question: what data types are actually stored inside of this category? And to answer it, we have integral numbers, so numbers without a decimal point, both signed and unsigned, of course. We also have floating point numbers, which basically are numbers with the decimal point. We also have characters, which are letters, numbers, special characters and stuff like that. And we also have conditionals, so-called Boolean values, and there we only have true or false. Those are basically all the scalar data types. And for our second category, we have compound data types. And compound data types are basically just collections of scalar data types. And Rust has two main representatives in this category. We have tuples and we have arrays. And now I feel like I need to give you at least some basic information about these two types, because they will both get their dedicated personalized video lessons where we will go in depth and explain everything about them. But for now, until that point, I want you to have at least a basic understanding about them. Tuples are your go-to type for grouping together sets of values that are all of scalar types, and they do not have to be of the same type. You can put together integers and characters and booleans inside of a single tuple and then have access to all of those different things from the same variable. So you can group together values that do not have to be of the same type, as you can see on the screen. As you can see on the screen, I said. There you go. Tuples can contain different values of different types, and each value is separated by a comma. And now let's cover arrays as well. And the story is very similar here as well. So arrays are basically collections of data, but with a significant difference when it comes to tuples, which is the fact that the data types have to be the same for all values. You can store as many values as you like inside of arrays, but all the values must be of the same data type. So you cannot do characters and integers and booleans in the same array. You need to pick and stick to that data type that you have chosen. And that's basically it. And you can see basically in our presentation here how it looks like in Rust. As I already mentioned, we are going to cover each of the data types that we mentioned in this video in its own standalone video or videos. Because some of data types are more complex than others and will require more than a single video lesson to explain it thoroughly. But for now, I feel like we're done with data types. I mean, I know that this was a very general approach and it was introductory, so to say, but I hope that you got some value out of it. And now I would like to use this opportunity to thank you all for joining this channel and liking videos, because it really helps out the channel grow. And right now there is only one thing left, and that is to tell you that in our next video we are going to talk about number data types in Rust. Finally, some concrete stuff to cover. And as usual, I wish you an amazing day. Goodbye!